Okay, we'll see today experiment number 3 of high voltage engineering, sphere gap voltmeter. Now, if you will see, title is quite different than what you learn in second year. You use this sphere gap for air testing. Okay, air is there between the two spheres. You applied the voltage. You went go on increasing. Means if you will go on increasing the voltage, air breakdown occurs, and you can find out breakdown voltage for a certain gap distance, and then you can find out breakdown strength. So this is the experiment, but here objective is different. Objective is sphere gap voltmeter, means how we can use the sphere gap for measurement of unknown voltage. One complete unit is there, fourth unit is on measurement of high voltage. In measurement of high voltage we'll see this method, how we can use only simple two sphere gaps for measurement of unknown voltage. So here this experiment will conduct, but even if our objective is different, experiment will be in the same way. Keep certain gap distance between the electrode and find out the breakdown strength of air. Okay, and afterwards then we will see how we can use that readings for finding the unknown voltage, and whether we can use two spheres for measurement of unknown voltage or no. So that is the objective. But how we can measure two spheres for measurement of unknown voltage, that we will see today. Okay. And then you will conduct the experiments using virtual lab. But now in virtual lab there is some difference. Even if we are getting this device, two spheres and gap we can adjust, and we can increase the voltage, and we can find out at what voltage flashover takes place. Okay, that will be flashover, not the breakdown voltage, but we will say that it is breakdown voltage only, same as if we perform in with the two spheres. And only difference is that we need to apply sinusoidal voltage, very high voltage across the two electrodes. But here in the virtual lab available on IIT Kharagpur website, virtual lab website, we will find out impulse voltage. That will be the difference. Impulse voltage we have to also just go want to learn it, but that will be not sinusoidal voltage. So nature of voltage is different. So that will be only two differences in our experiment which we need to perform, and what we will perform on virtual lab. So aim of this experiment is to measure high voltage using sphere gap voltmeter as per Indian standard specifications. So of course apparatus and test circuits will be same as usual. You know the generalized test circuit that will be always used. Means 230 volt supply from the lab we will give it to auto transformer. Then auto transformer output will give to the primary winding of the transformer. Then secondary winding of the transformer will connect across the electrodes. We have conducted two experiments. Okay. So same circuit diagram will be used. Here only electrodes are now spheres. We have observed the effect of shape of electrodes also. Uniform field, non-uniform field. In uniform field we have tested actually with this sphere gap air. That experiment already we have done, but here again we will do it. Okay, not under the heading uniform field. We are not using now these two spheres as a uniform field, but we are using those two spheres as a voltmeter. Okay, how only two spheres can be used for measurement of voltage. So procedure will be that if suppose you want to measure unknown voltage, say I don't know that voltage, but it is approximately 30 kilovolts, say, and I want to measure that unknown voltage. So what I will do, these two spheres I will keep at a very higher gap distance. Okay, so two spheres gap should be used at a higher, means initially gap distance should be higher, and if we will use gap distance higher, then slowly we will go on increasing the decreasing the gap distance. So first keep this gap distance at a higher distance, then apply unknown voltage across these two spheres, and then go on decreasing the gap distance. Usually in our experiment what we do, we keep the gap certain fixed value 1 centimeter or 1.5 centimeter, and then we are increasing the voltage to find out the unknown voltage. Here reverse procedure is there. We are just keeping at a higher gap distance. We are giving unknown voltage across the two spheres, and then slowly we go on decreasing the gap distance. And when we are decreasing the gap distance, then at a certain gap distance spark of the air will take place. because unknown voltage is there and the gap is going to reduce, and at a certain gap distance, that 30 kilovolt or whatever is unknown voltage will cause the breakdown of the air. Now circuit breaker will trip. High voltage supply we have to isolate, then we have to discharge this gap, and then we have to go and measure the gap distance. So in this experiment we required gap distance, okay, and always we find out breakdown voltage. Now what we'll do, we'll perform in similar way only, but whatever breakdown voltage of certain gap we'll use, that gap distance we will take for the calculations of finding unknown voltage. The calculation part we'll see in next practical. Today we will just have set up the readings, because as we are having the two spheres on virtual lab, we will also see effect of gap distance, increasing the gap distance on breakdown voltage. We will also observe the effect of diameter of the electrode, okay. So go on increasing diameter of the electrode and see at a certain fixed gap distance breakdown voltage will increase or decrease. So that will be our side by objectives and conclusion, okay. And then we will take in next practical we will take any gap distance and we will find out unknown voltage. Now these problems are also asked in theory exam. So if you know the gap distance, if you have measured the gap distance at what spark takes place, then calculation of unknown voltage starts from that. How a certain gap distance can give you unknown voltage? No, I am giving you example 30 kilovolt is applied. I don't know that it's 30 kilovolt. And I have decreased this gap distance and I got the spark. And I will measure the gap distance and suppose I will get certain gap distance. Suppose this gap distance is this IS table, we have to use it for calculations. Okay. So this IS table we will refer. So this is the gap distance and these are the sphere diameters. Suppose our sphere diameter at the time of testing is 10 centimeter and gap distance at what spark occurs, I got suppose 1.5 centimeter. Okay, so what will be unknown voltage? That will remain standard. Why we can use sphere gap for measurement of unknown voltage? We can use only two spheres for measurement of unknown voltage, because the fact is that if we get certain gap distance, breakdown voltage of that gap distance remains same. This is the situation why we use sphere gap for measurement of voltage. If we get the gap distance between the two spheres, at what spark occurs, we can predict from the gap distance what was that unknown voltage. Therefore, it will work as a voltmeter. So, I got suppose spark of the air at 1.5 centimeter when diameter of the electrodes were 10 centimeters. So, I will proceed further to predict the unknown voltage. I will open this Indian standard table. I will see what is my diameter of electrode. I will find out gap distance and I will say 40.58 is my unknown voltage. But this Indian standard table is for standard pressure and standard temperature. But when we perform the experiments in lab, when I am using that virtual lab, I don't know what is today's pressure and today's temperature. So I will note down the pressure and temperature in the lab, at what time I will get the breakdown voltage. Then I will find out air density factor delta. So write down this air density factor delta, you need to calculate. So you note down today's pressure and today's temperature from internet. On mobile you can get today's pressure and today's temperature, and then just keep this delta ready, because you will be taking readings today. So what is today's pressure and today's temperature? Now, as Indian standard table is for standard pressure and standard temperature, but lab pressure and lab temperature is different, we need to find out air density factor delta. So write down delta will be equal to P upon 760 into bracket 293 divided by 273 plus T. Then find out delta. First step is find out delta for today's pressure and temperature. Then after finding air density factor delta, you can find out correction factor K using this Indian standard table. Okay. So find out correction factor K. And this correction factor, suppose delta I will get 0.85, then I can say the correction factor 0.86. Now question comes, if suppose gap distance I will get which is not mentioned in Indian Standard Table. I am getting gap distance 1.2. Now it is not mentioned in Indian Standard Table. So you know you have to do extrapolation either by calculations or by graphs. So you can plot the graph of gap distance versus breakdown voltage for 10 centimeter diameter. So all these gap distances are given. Plot a graph and from the graph you can find out at gap distance 1.2 what will be the voltage. So it will be between 31 to 45. Okay. So from the graph or from extrapolation method you can find out at any desired gap distance that measured unknown voltage from the Indian Standard Table. Then similarly that may happens for K. Whatever delta you are getting it is not in the table. Suppose 0.8 and 0.85 you will get 0.83. Suppose delta is 0.83. So this also graph you have to plot delta and K, and from that delta graph you can find out for 0.82 what will be the K or extrapolation method. Okay. So graphs will require to draw in your calculation methods. Okay. So this is one step. So find out delta, then find out K. Then what will be your unknown voltage? Your unknown voltage will be V is equal to K into V0. Write down formula. Unknown voltage V is equal to K into V0, where K is correction factor, which is found out from air density factor delta, and V0 is the voltage measured from Indian Standard Table. V0 is the voltage measured from the Indian Standard Table for standard pressure 760 and temperature 20 degree. Okay. So our V0 is 45.8. So I will multiply by K to this 45.8. That will be my unknown voltage V. But this unknown voltage is peak value. Right down. Voltage V is the peak value because whatever voltage we are getting from the sphere gap, air gap testing, that will be peak voltage because spark breakdown occurs at peak voltage. But generally when we measure breakdown voltage from voltmeter, that will be RMS. Write down. This V is peak voltage. So converting peak voltage into RMS voltage, you find out V dash. V dash you find out. Now whenever we conduct experiment, we also get the voltage from the voltmeter. So here in this experiment also, you will do the procedure. You will keep certain gap distance and you will find out breakdown voltage. That breakdown voltage will be RMS value and that you can measure from the voltmeter. Now we have to check whether the calculated voltage from the Indian Standard Table is near about the voltmeter reading, yes or no. If yes, we can say sphere gap can be used for measurement of voltage. If no, then we have to discuss why we cannot measure this, why our measured value from sphere gap is not same as voltmeter. Okay, so let us start the experiment. So as usual, go in virtual lab. Okay. So go to www.vlabcoin. Your any browser you go and type www.vlabcoin. Just write down the steps. As usual, you will perform on virtual lab. You will share me readings. I will mark the performance marks, and then our practical will be finished. Okay, you have to post your readings in the chat box, and readings should not be copied. There are different set of readings. You take your own readings. So VLab coin, if you'll go, or you can just write down the steps. Go in electrical engineering lab. Down you will see number of labs and in that you will go electrical engineering lab. Now in electrical engineering lab you will go high voltage lab, IIT Kharagpur. Write down steps and then you can perform. Go in IIT virtual lab, high voltage lab, IIT Kharagpur. And then in IIT Kharagpur you see the experiment list. Now experiment list is sphere gap using IVG. IVG is impulse voltage generator and this is critical flashover. So we are not finding critical flashover. We are using this just test setup and water flashover voltage we will get. We will say it is the breakdown voltage of air. Okay. Two modifications are there. First we are using impulse voltage, not the sinusoidal voltage. Second, here flashover voltage is seen. Okay, so we will consider because procedure is same. Okay, so let us click that sphere gap impulse voltage. Now theory and all this, no need to read it because our objective is different. So just click on simulator. And you note down, because I am finding students are just performing in the way it is given in this write-up. Why am I am explaining? I am explaining whatever readings I will tell you, you have to take that readings, not the readings given here. So your observation table should be specific only. So you have to click on the IVG, impulse voltage simulator. So here is the test circuit. So you can just see here we are getting sphere gap. We are using this vertical arrangement. In our lab we have vertical and also horizontal. Okay. So these two spheres we are using, and here it is insulated with the air, and we have to carry out the experiment finding the flashover voltage of the air. Okay. Now here this is the impulse generator. You need to study this in depth. Okay. So for oral exam you have to be ready for explaining this. So here when I will simulate voltage, this impulse generator will trigger and very high voltage, high impulse will be given across this. Now whether this electrode will withstood that voltage, withstood means nothing will happen. Breakdown will not take place, flashover will not take place. Then you have to increase voltage here manually. Here no auto transfer is there, so manually increase the voltage. Again repeat the experiment, find out spark occurs or no, and you have to find out at what voltage spark occurs for a certain gap distance. Okay, so let us start the experiment. To start the experiment, note down, select the sphere diameter. Now you start from 200, because always I am finding you are taking readings here only, and the readings are coming same. Your reading should be different. So select any one diameter. Suppose I have selected 25 sphere diameter. Now for this one diameter you have to take three rings. Write down. You are giving me different observation table. Today I will not accept. Sphere diameter 25 centimeter for three readings. Same. Keep this same. Now gap distance will be 3, means you have to take reading for the 3 gap distance maintaining sphere diameter same, not 25 of your choice. It should be different. So first gap I will start with 2, 25 and 2 centimeter. Okay, so 25 and 2 centimeter. I am showing you take differently. Now I have to select voltage. Start from initial voltage. Start from initial voltage. So I have adjusted now readings. Now I will start the experiment. Start the experiment. Trigger the generator. See here. Generator is started. Now here observe. So nothing has observed. So whatever is coming, air has withstood. No flashover of air took place. So for the voltage 16.72. It has withstood. When it will fail, when flashover will take place, I have to find out that voltage. Now here I cannot increase the voltage. So again I have to go back. I have to simulate it. I have to click on the simulator here down, and then I have to keep same readings because I have to take three readings. So don't forget to maintain same diameter. Then sphere gap was 2. Okay, remember that. Now voltage first we have observed. I am increasing the voltage. Voltage should be increased in the sequence. Start the generator. It will trigger. See, and see here what happens. See, nothing has happened. So that it has also again withstood. Okay. So for 17 also it has withstood. So again start. Again increase the voltage. Okay. So simulate it. Now again same, miss, this is first reading is going on. Don't confuse. First reading is going on because voltage we cannot increase with the auto transformer. So this is first reading is going on. Now first is over, second voltage is over, third voltage. Now I will just start. I will give the voltage. Now see here spark occurs or no? Yes. Now spark has occurred. So as soon as spark has occurred, air has flashed. So immediately voltage has gone to 0. So see flashover has occurred. So this is our first reading for 25 centimeter diameter for 2 gap distance. We got the breakdown voltage or flashover voltage 18.68. So this is first reading. Diameter 25 centimeter will not come in observation table. You write down above observation table. Above observation table you write down gap diameter 25 centimeter. Then gap distance was 2. and breakdown splasher voltage was 18.68. So what will be the your observation table? Observation table will be like this. Here you write down sphere diameter. Okay, sphere diameter 25 or whatever you will take. And first reading, second reading, first reading gap is 2 centimeter. Voltage you got 18.68. Okay. Now increase the gap distance. Now increase the gap distance. Okay. Now simulation. 25 centimeter diameter and this gap distance now 2, instead of that increase it 3. This reading should not be same. Oh? Now select the voltage. I will start from the first voltage. Start the experiment, trigger the generator, and similarly you observe here and find out the spark voltage. Okay. So students, that will be first observation table of effect of increasing gap distance. At least 3 readings you take. At least 3 readings you take. This will be first observation table where we are observing the gap increase, effect of gap increase. Now diameter was 25. Now what you do? Second set you will just take. Second test here you will go on varying diameter. First will be 25. Second will be suppose 30. Third will be suppose 40. Now any gap you can choose from this. Suppose I will choose gap distance here. First only 2. Okay. So gap distance will be here same. Gap will be 2 centimeter. So that will be above observation table. Whatever remains constant, that you need to write down above observation table. Now for 25 diameter to find out breakdown voltage. So here breakdown voltage, breakdown voltage, breakdown voltage. Gap you are maintaining same. Okay. Now you are observing here increase in the diameter. What will happen with increase in the diameter? So your observation table will be 2. So your conclusion from the first table will be as gap distance increases, what happens to breakdown voltage. Second conclusion will be as diameter increases, what happens to the breakdown voltage. So as diameter increases, gap distance you have to maintain constant. As gap distance increases, diameter you have to maintain constant. Okay. So 2 sets you will take and third set will be actual our experiment gap sphere gap voltmeter. So at that time we will select any gap 2 centimeter and we will proceed further. We will calculate the voltage using Indian standard table, finding air density factor delta, correction factor K. We will find out the voltage and we will tally whether our that we have just seen V is equal to K into V0. So we will find out V, then we will find out V dash RMS value, and that RMS value we will check with this voltage measured. And then we can say yes, sphere gap can be used for measurement of high voltage. So this third part we will see in the next practical, and problems are asked. If the observations are given to you, then it will be asked do the calculations. Okay, so you just see from gap distance how to proceed to the voltage. Okay, so by applying correction factor K, finding delta with that it will require to solve it in the problem. Okay, now you carry out the experiment, write down the conclusion, write down your name, serial number, because whatever observation table today you will write down in rough notebook, whatever you will share me, that same you have to paste it in your journal. Okay, so same observation table calculations you have to paste in the journal. So write down name and write down observation table A, observation table B, write down conclusion 1, conclusion 2, and then same you will post me in the chat box. Okay. So that will be completion of our experiment number 3 on sphere gap voltmeter. Okay. We are observing various things.